This is lesson 4.4, the fundamental theorem of calculus, or we commonly call it the FTC. So today we're going to come back around to doing some actual math after we go over what the fundamental theorem is about. And so we're getting back away from the area part. This will be a lesson you will enjoy, especially if the last two lessons have not been that much fun for you. So talking about the fundamental theorem of calculus, and we call it part 1. Later on, we're going to study the fundamental theorem of calculus, part 2. The first fundamental theorem says, if f is a function on the closed interval from a to b, and capital F is an antiderivative of f on the interval from a to b, then if you integrate from a to b the function f of x dx, you're going to get capital F of b minus capital F of a. So what that means is if we take the antiderivative of this f of x, which is what we did in lesson 1, 4.1, if we take the antiderivative and plug in whatever the b value is and plug in whatever the a value is and subtract them, making sure to keep b first, then you're actually going to get the answer for the definite integral. Okay? So, why is this called the fundamental theorem of calculus? Well, it's fundamental because this is where we kind of see derivatives and integration. How do they connect to each other? So, in general, when we talked about integral, it's really talking about area under a curve. And we did the trapezoid rule, the midpoint formula, or the midpoint sum, left and right Riemann sums. We did all that stuff to find areas. That's what integration is. Well, how does that connect to derivatives? Well, if you have a derivative, if your function starts out as a derivative and you integrate it and then plug in the values that start and stop your interval, then you actually get a solid number, which is the area under that curve. So basically what I'm going to be doing is showing you some examples that will show you how to calculate the things that the book was giving to you before, the given part of the problems. Okay? And it's really easy. I think you'll be really glad about this part. So first of all, we're going to integrate what we've got. And remember that to integrate it, we take x to the third, and we're going to make it x to the fourth divided by 4. Used to we had plus c. No more plus c because we have what's called a definite integral. So I'm just making this little bracket, and it's going from 1 to 3. So basically I'm just saying here is the antiderivative. Now I'm going to plug in the 3, and I'm going to plug in the 1, and I'm going to subtract them. Okay? So that means 3 to the 4th over 4 minus 1 to the 4th over 4, which is 81 over 4 minus 1 over 4, which is 80 over 4, which is 20. So the definite integral of x cubed dx from 1 to 3 equals 20. In other words, that's the area under the curve on that interval of from 1 to 3. Okay, so let's look at another one. All right, so let's integrate this. X squared becomes x cubed over 3. 3 becomes 3x. We don't need plus c. We have 1 and we have 2. So first I'm going to plug in the 2. Then I'm going to plug in the 1. Then I'm going to simplify. 8/3 minus 6 minus 1/3 plus 3, because this is distributing the negative. So that actually is going to give me 7/3 if I group these two. Minus 6 plus 3 is minus 3. So I get negative 2/3. So the definite integral of x squared minus 3 from 1 to 2 is equal to negative 2/3. And since it's an area, that might make you say, is that possible? That is an area. So if you get a negative answer, that just tells you that more of the function, more of that area is below the x-axis than above the x-axis. So this is the cumulative area from 1 to 2. Okay, next example. First, let's rewrite it as 3x to the 1/2 power dx. Now let's integrate it. So that's 3x to the 3/2 power. Sorry, I scribbled there. divided by 3/2, which is the same thing as multiplying it by 2/3. And we're going to go from 1 to 4. So simplify this first. This is 2x to the 3/2 power from 1 to 4. So now plug this in, and you get 2 times 4 to the 3/2 power minus 2 times 1 to the 3/2 power, which is going to be 2 times 8. In case you're wondering how I got that, if you take the square root of 4 and then do it to the 3rd power, the square root of 4 is 2, 2 to the 3rd power is 8. Minus 2 times 1 to the 3/2 power, it doesn't matter what the power is when it's 1, it's always 1. So this is 16 minus 2, which is 14. So the cumulative area from 1 to 4 of 3 times the square root of x is going to be 14. Okay, let's look at some trigonometry. If I have secant squared, it integrates to become tangent. We're going to integrate this from 0 to pi over 4. So we're going to plug in pi over 4. So tangent pi over 4 minus tangent of 0. Tangent pi over 4 is 1. Tangent of 0 is 0. So that area right there is just 1. Okay? Hopefully you're to the point that you're saying to yourself, this is not such a bad deal. Okay, what about absolute value? Well, of course, absolute value has to be different. So basically, just keep in mind, when you have an absolute value function, like this one, just keep in mind, it's really a piecewise function. Absolute value is always a piecewise function. And for this one, I'm going to write it in its 2 pieces, but it makes it a little easier for me if I draw it first. So 2x minus 1, well, it's been shifted to the right 1 here. Actually, it's been shifted to the right 1/2. So this is 1 and this is 2. And so it actually looks like this. And it's okay to graph that on a calculator so you get a little bit of an idea. So it crosses this at 1 and at 2. So when you plug in 2, it crosses 3. Okay, so this is what we're talking about, is the interval, and I'm going to color it in so you can see. This is the interval that we're talking about. Okay, so what is my piecewise function? Well, this line over here on the side, I'll show you again, that's what I'm talking about. This line is negative slope of 2x, and it crosses the y-axis at positive 1. And then this line would actually, if you continued it out, it would have a positive slope of 2x, and it would cross the y-axis at negative 1. So those are the 2 piecewise functions. And the vertex is where it's going to switch, which is going to be 1/2. And it doesn't matter really whether you put the equal sign up here or on the second part. Okay, so why is this so important? Well, you have to break it up if you're going to integrate. We've got to break it up into 2 integrals. So since we're going from 0 to 2 and there's a breaking point at 1/2, we're going to say 0 to 1/2. And we're going to use this section because 0 is less than 1/2, so negative 2x plus 1 dx plus the integral from 1/2 to 2. And we're going to use this part, 2x minus 1 dx. And I'm going to integrate that as 2 separate things. So I'm not going to go through the entire, all the everythings. Some of it you're going to have to do a little bit on your own. But negative 2x squared over 2 plus 1 becomes x. This is going to be integrated from 0 to 1/2. And then this one on this side is going to be 2x squared over 2 minus x, and it's going to be integrated from 1/2 to 2. A lot of times I like to go ahead and close the bracket around it, especially if you have 2 integrals. And then, so on the left side, you would have to go ahead and plug in the 1/2 and plug in the 0 and subtract it and all that. So let me just go ahead and tell you that when you do all that process, oh yeah, good, I didn't write down the answer. When you do all that process, you're going to get the answer. So let me erase some space. Hopefully you've written all this down, because I got to have some space up here. Okay, there was still a 2 there. Okay, so I have negative 2x over 2. The 2's are going to cancel in both places, so when I plug in 1/2, it's going to be 1/2 squared, because the 2's are gone. Sorry, should be a negative on the outside. Plus 1/2 minus, plug in the 0, so that's going to be 0 squared, which is, of course, 0, plus 0. So that's the first grouping. Plus, now the reason it's plus is because we had to break it, remember, into 2 functions. So we integrate the 2 functions and then add their areas together. So this over here, the 2 canceled, so I'll have 2 squared minus 1/2 minus, 2 squared minus 2 minus 1/2 squared minus 1/2. So over here I'm going to have negative 1/4 plus 1/2. I'm erasing stuff down below. I hope you already had this written down. Minus 0 plus 4 minus 2 minus 1/4 plus 1/2, because I'm distributing the negative. Combine your like terms, so 4 minus 2 is 2. We don't need the 0. 1/2 plus 1/2 is 1. Negative 1/4 and negative 1/4 is minus 1/2. So I have 3 minus 1/2, which is 2.5. So the area of that absolute value that I had shaded in for you is 2.5. And you can think of it in terms of units squared or however you want to, but really we just need to know it's 2.5. Okay, now that we've done all this, we have to add something else to it. I don't know why, but average value is something that's very important to know. It does go with this section, so we're going to go ahead and do a little bit with this. Average value is super simple. We're still doing all the integrating part that we just did. The only difference is we're putting something in front here. So a lot of people like to think of it like this. Since it's an average, basically you're integrating from a to b, f of x dx, and then you're going to divide by whatever this number is, b minus a. Because look, it's 1 over b minus a, so it's really the integral divided by the range. Okay? So it's just one extra step. Now what this finds for you with average value is that, for example, on the 4.2 quiz, you integrated a velocity to get the miles, how many miles it was, so the miles turned out to be the distance. So an example for average value is, what if you wanted to find the average distance that's driven on each interval? So it's basically just averaging the total. Alright, so how would this one look? Well, we would take the integral of 3x squared minus 2x dx from 1 to 4. And we would divide by 3, because 4 minus 1 is 3. So this is going to be 3x to the third over 3 minus 2x squared over 2. And it goes from 1 to 4. And then we're going to divide by 3. So stay with me. We're going to cancel the 3's and cancel the 2's. So it's really x to the third minus x squared from 1 to 4 divided by 3. So 4 to the third minus 4 to the third minus 4 squared minus 1 to the third minus 1 squared divided by 3. So this is 64 minus 16, which is 48. 1 minus 1 is 0, so 48 minus 0 is 48. Divide by 3, and you get 16. So the average value on this interval is 16, so basically it's telling you like an average y value that works on this interval. And that's how you find average value. It's really simple. Okay, so here's your assignment. 5 through 31, you're going to be using the fundamental theorem. You're just going to be integrating, plugging in the b and the a, and subtracting. And then these two problems are going to be average value problems.